Alright, so continuing on with this one, we're going to look at what's happening as t approaches 0. So we're over here now. Alright, so as t approaches 0, so we want to look at walking along this graph from the left and the right as x approaches 0. So we're coming in from this direction from the left, and it looks like from this direction from the right. That's the path that we have. Now, it doesn't look to me like if we come in from the left and the right that we're going to approach any common y value at all. So that limit is something that we call just simply does not exist. And I am going to summarize this as D and E from now on out. So that means does not exist. Now keep in mind what I said. It does not matter what happens at the value of 0. So the fact that we actually have a value here does not matter. What matters is that those two paths are not going to a common point like the other parts where we were approaching -2 and -1. Those were approaching a common point. That one does not. So that limit does not exist. And then the last part of the question is what happens as t approaches -1/2. So I would say that looks like as t approaches -1/2, so we're approaching roughly this point. So coming in from the right, coming in from the left, it looks like it doesn't matter. We are staying at -1. So our y value is -1 on that one. Okay. Let's go down to number 4. This one was actually a true-false question. So I will just highlight or circle my answers as true or false. So part A was, what is happening as x approaches 2? Does that limit exist or not? So part A and B actually kind of are about the same thing. So let me get my highlighter up here. So if we look at what happens as we're approaching 2, from the left, we're moving along this path. From the right, we're moving along that path. So, and like I said before, it doesn't matter what actually happens at 2. So you can cover that section up because what actually happens here is insignificant. What is significant when you're looking at a limit is the path. So these two paths look like to me like they're both approaching 1. So a y value of 1. So I would say that it does exist. So on part A it says that it does not exist. That's false. On part B it says that that limit should be 2. I would say that's false. And that's because the limit as x approaches 2 for this function should be 1. Okay. So next part of it is what happens as x approaches 1. So as x approaches 1, coming in from the left, looks like we're along this path here. Coming in from the right, we're up here. Those two roads are not leading to the same place, not the same destination, so that limit does not exist. So I would say that part C is true. The last two are generic. So part D is the limit as x approaches C for the function exists at every point between -1 and 1. So it wants to know, do we have a limit everywhere between -1 and 1, not including, because this is an open interval, so that means not including the endpoints. So we don't want to actually include -1 and 1. So that just means if we look at the entire graph between -1 and 1, would we have a limit at every single x value in there? And I would say, yeah, we do. There's no, there's no reason whatsoever why we don't have a limit everywhere. Now between 1 and 3, I would say that same thing, we do have a limit everywhere. Only point where we would have a problem would be at 2, and we do have one.